Assalamu alaikum dear students, welcome to second lecture of chapter 1, that's measurements. So we have to discuss international system of units. So let's see what is this. With the development in the field of science and technology, the need for a commonly accepted system of unit was seriously felt all over the world, particularly to exchange scientific and technical information. The 11th General Conference on Weight and Measures, held in Paris in 1960, adopted a worldwide system of measurements called International System of Units. So when you interchange information, so we know that all the physical quantities, they have more than one unit. So what this international system of units is about, we keep the units same all over the world. So if let's take an example, if I measure the time, so international system of units suggests that the unit of time will be seconds. So if I'm here in Pakistan measuring time, I'll use seconds. If someone else is in the Middle East or Europe or wherever he's doing the experiment, he will also use the unit standard unit, that's standard unit of time, that's seconds. If we even get a unit of time other than seconds, we can convert it back into the standard unit. So understanding SI unit, each physical quantity can have more than one unit. I just told you that. So we are gonna take another example, that's length. So length can have several units: millimeters, centimeters, meters, and kilometers. But international unit system says that the standard unit of length, whenever you do calculation, it will be meters. So if you get your reading from another person or another source or an instrument which does not record its reading in meters, so you will convert that into the standard unit, that's meters. So kilometers, so if you get your reading in kilometers, when you're doing the calculation, you will convert it into the meters. So the same is case for centimeters and millimeters. All right, so next one. Is scientific notation. So now scientific notation is scientific notation is a number expressed by some power of 10 multiplied by the number between 1 and 10. It's another way to express any number. So example is given here. So after this slide, I'll solve some examples as well. So what happens is we have very large numbers and we have very small numbers. So scientific notation allows us to write very small and large numbers with the help of power of 10. So a number is expressed in power of 10. So we are looking at this example 62750. So we can move its decimal is at the end, that's on the right hand side after the 0. So we can move that decimal to the left hand side, and it can be expressed in power of 3, 10 raised to power 3, so 62.75. So we move the decimal 3 times to the left and we can write it down as 62.75 into 10 raised to power 3. Similarly, if we move the decimal to the left hand side 4 times and take our decimal to between 6 and 2, so it will become 6.275 and into 10 raised to power 4. Similarly, you can also move the decimal to the left hand side. So whenever we move the decimal to the left hand side, we add 1. If we move 1 time to the left hand side, if we move the decimal 1 time to the left hand side, we'll write it as 10 raised to power 1. If we move the decimal 2 times to the left hand side, we'll write 10 raised to power 2. So if we that's the case when you move from left to right. So if you're moving the decimal to the right hand side from left to right, it will be reversed. You will be subtracting from the tens power. So look at the example at the end, that's 0.00045 seconds. So we're going to move our decimal to the right hand side 4 times, so it will become 4.5 into 10 raised to power minus 4. We'll also discuss this in detail later. scientific notation. So its definition is pretty simple. A number expressed in two features: power of 10 multiplied with a number one to 10. So let's take a number. So what does this mean? Let's take an example. So you have a number, let's say it's 250,006. Oh, let's make it 000 kilograms. So we know that the decimal is here. So each time you move your decimal to left hand side, you get a power of 10. So if I move this decimal to this place, 1, 2, 3, 4, 5. So I'll write it down as 2.5 into 10 raised to power 5, and the unit will remain as it is. So this is the standard form. A number, so this is the first part of the definition, power of 10 multiplied with the number between 1 and 10. So that's your standard form. If I can write this number in this way as well, 25 into 10 raised to power 4 kilograms. So these three numbers are expressing same number, but the decimal is right here. So this is not a scientific notation. So this is a correct form, but this is not, this won't be called as scientific notation. In order to make it scientific notation, the decimal should be always after the first digit. So if it's not after the first digit, this number will not be between 1 and 10. So this is standard form. Standard form, scientific notation is also called standard form. And this is not standard form. So similarly, you can also make very small numbers. Let's make them. So write it down. You can pause the video and you can write it down. So I'm going to give you another example. So that will be for small number. So this is example 2. So let's say you have number 0.00025. Let's make it 35 meters. So now what we want to do is we want to move this decimal after the first non-zero digit. That's 3. So when you move your decimal to the right hand side, the power of 10 is subtracted. So we can write this is 1, 2, 3, and 4. So we will write this one as 3.5 into 10 raised to power minus 1, 2, 3, 4. And meter will come as it is. So this is now standard form. So if you don't remember, what's happening here when you move the decimal. So I'll give you another example. So let's say you have a number, let's say 350 into 10 raised to power, let's say 3. We're not mentioning the unit right now. So what we want to do is, if you move your decimal to the left hand side, a number will be added number of times the decimal moves. You will add that number here. So decimal is moving 2 times, it will become 3.5 into 10 raised to power 5. So if you move your decimal to the right hand side, so let's say, so this is 10 raised to power 3 again. So the decimal is here, I want to move it further away. So there are zeros here. So let's say I want to move the decimal over here. So I'll subtract, if I want to move the decimal on the right hand side 2 times, I'll subtract 2 from this power of 10. So this will become 35000 into 10 raised to power. So it will be 1. So if you move your decimal to the left hand side, power of 10 will increase. And if you move your decimal to the right hand side, power of 10 will decrease. Okay, coming back to the example. So this is standard form. I can also write this number as 0.35 into 10 raised to power minus 3 meters. But again, this will not be standard form. Not standard form or scientific notation. Or scientific notation. So this is scientific notation or standard form. So I hope you understand this, and you can try out examples from your book as well. So now prefixes. Prefixes are words or letters added before SI unit, such as kilometers, kilo, mega, giga and milli, etc. So this table right here shows all the prefixes involved. So now we're gonna take few examples, and I'll explain this in detail. The topic we're going to discuss now is prefixes. A word, so we're going to define it. A word. Let's make it official. Words or letters. Words or letters added before SI units for example, milli, giga, micro, etc. What does this mean? So we know that our physical quantity is expressed with the help of magnitude and unit. So I'm going to give you 2 examples. This is example 1. You will also find a chart of prefixes in your book. So I'm going to give you example. So let's say we have a number 35000 meters. So common prefixes are kilo, which means 10 raised to power 3. You have mega, it means 10 raised to power 6. You have micro, milli, that means 10 raised to power minus 3, and you have micro, it is equal to 10 raised to power minus 6. So we have studied in standard form. If you move your decimal to the left hand side, you get the power of 10 increases. So I'll move this decimal right over here. So I'm moving the decimal 3 times. So it will be 35 into 10 to the power 3 meters. So I'll look up to the table and see which is a suitable prefix. So if I look here, so this is kilo equal to 10 to the power 3. So I'll replace this 10 power 3 with K, its symbol for kilo, and I'll just write kilometers. So you have to notice in the previous lecture we discussed the standard form. For standard form, you have to move the decimal right after the 3, but we're not changing into a decimal form. We are just adding a suitable prefix to express our number. So for very large numbers and very small numbers, we use these prefixes to represent them easily. So let's take another example. So example 2. So now we're going to take a very small number, 0.0000036. Let's say meters. So let's see. Now let's move our decimal. So if we look at these or prefix table, we can use a suitable. So let's see 1, 2, 3, 4, 5, 6. So if we move the decimal 6 times, so it will become 3.6 into 10 to the power minus 6 meters. So we know that from our table 10 to the power minus 6 represents micro, so we'll use the symbol of micro meter. So if you look at the definition again, words or letters added before SI units. So this is meter is your SI unit, and you're adding this letter before your unit to express 10 to the power minus 6. So this is a prefix. So I hope you understand this and you can apply this on the question in your book. That's it.